Hello friends, today I'm going to solve LeetCode problem number 1035 uncrossed lines. In this problem we are given two integer arrays nums1 and nums2 and what we are gonna do is we write all the integers of nums1 and nums2 into separate horizontal lines like given in this example, where 1 4 and 2 are the integer elements of nums1 and 1 2 4 are integer elements of nums2. All right, now what are we going to do is we start connecting lines between the integers from nums1 and integers from nums2. So there are conditions that we need to consider while drawing the lines. So first condition is that the element in nums1 should be equals to the elements in nums2 to draw the line, and the line we draw should not intersect any other connecting lines. Okay, and even it should not intersect at the end points. So here we have like 1 4 2 1 2 4. Okay, so we take the first integer 1 and we draw the line with integer 1 because these two are equal. Now for the value of 4 we know that this is equals to this 4. Okay, so we draw a line between these. Now when we take the value 2 here, we see that we have a value 2 here. So while we try to draw the line between these two, we are actually intersecting the line between 4 and 4, right? So that is not allowed, so that is why we do not draw the lines. So the maximum number of lines that we could draw for this integer is equals to 2, right? One between these and one between these, or we could either take the lines between 1 and 1 and between 2 and 2, that would still be 2. Okay, so that is the answer for this example. Now let's see how we could solve this problem. Okay, so let's take an example. So I'm going to start with two integers, like two arrays, nums1 and nums2. Each of them first have only one integer. Okay, so what happens is both of them are equal, right? So we just connect with them with one line. So what was happening is before, where there were no elements, we did not have any connection, right? So there were zero connections. Now we added one element to each of the array. Okay, this is nums1 and this is nums2. Okay, so I'm just going to represent with n1 and n2. All right, so we now have these two arrays and each of them are equal, so we can actually draw a line between them, right? So now the number of connections increased from 0 to 1. Okay, so we are just going to increment our number of count from 0 to 1. Okay, let me just write it this way, from 0 to 1. Okay, now what happened is I am now adding one value here to integer number into our array n1. So what are we going to do is now we are again going to check for the connections with 3. Okay, so what we do is we check connection with 1 1 and we found that these are connected. Okay, but like we try to check connections for 3 but we did not find any connection, right? So for 3 we have 0 connections, but for we already have one connection here, right? That is this connection of count 1. So we are just going to take that connection as our number of connections, right? Total number of connections, even though 3 is not connected with any other elements. Now let's add one more element here, that is equals to 3. All right, so we added one more 3 here. Okay, and let's just erase this one. Now let's see. So we already have a connection between 1 and 1, so that is totally fine. Okay, we already have a connection 1 with 1. Now we check for the connection of 3 and we do not find any connection because there are no elements 3 in n1, right? So the total number of connection would be the connection for 1, right? That is the previous number of connections that we have, which is equals to 1. So 1 becomes our answer. Now what happens if I add 3 to both of the array? Okay, so in that case we already have one connection between these two, right? So next we try to establish connection between 3, and we find that these two we can connect to these two, right? So now what is the connection, total number of connection? The previous number of connection that we had. Okay, so this is the previous number of connection, which is equals to 1, plus the current connection, which is equals to plus 1. Okay, so previous number of connection is equals to 1 plus 1, so we add plus 1. Now we get the value of equals to 2. Okay, so basically this is how we are going to perform our all our operations, rest of our calculation. So if I add a value 9 here and a value 5, okay, these two are not equal. So now when we are comparing 9, we actually need to check the connection for each of the elements in n2, and we see that it is not equals to 1. So like the connection between 9 and 1 cannot be established. However, if even though we do not establish the connection between 9 and 1, we can still establish the connection between 1 and 1, right? And also like so that would give us like a previous connection of 1, and like we again now try to establish connection between 9 and 3. Okay, so we are taking these only into consideration, only these many elements into consideration. Oh, okay, let me just read that. So we are only taking these many elements into consideration, and we try to connect 9 and 3. We already have a connection between 1 and 1. Now we are trying to connect 9 and 3. We also have a connection between 3 and 3, but we are not able to connect that, right? So what we do is we still have two connections in this configuration. Okay, so we take the connection number 2, which is this value coming from here. All right, now we compared 9 with 3. Now we are going to take this configuration, the whole configuration. So we compared 9 with 1, 9 with 3, and now we are going to compare 9 with 5. Okay, so while we try to do that comparison, we see that we are not able to connect it with 5 also. So we are just going to take these two connections. We already have these two connections, right? So we are just going to take that previous connection, previous number of connections. Similar we are going to do for 5. We check 5 with 1. Okay, and we are just performing comparison of 5 with 1, and then we see that we are not able to connect 5 with 1. However, we are able to connect 1 with 1. Okay, so that would still give us a count of 1. And now we increment the number of iterations that we make, and then now we compare 5 with the 3, and we are still not able to connect 5 with 3, but we have two connections in these, right? So that two connection is actually coming from here. These represents the connection between 3 and 3, right? We actually created these for this, and this was coming from here. Okay, so we are going to take that value here. Now while we try to connect 5 and 9, okay, now we are taking all of these 5 and 9, we see that we are not able to create a connection because these values are not equal, but we still have these two connections. Okay, 1 and 1, so we are going to take these two connections, so that would be equals to 2. And that is this value here, which we already did in our previous iteration while we were iterating for 9 with 5. Okay, so that is basically how we do. What are we doing is, if we found a new connection, we are just taking the diagonal element and we are adding 1, like we did here for 3. we also did the same for 1. Initially we are going to initialize every value with 0, and then we take the value 1, and now 1 we are diagonally adding 1 to 0, and next we add 1 to 1, and we got the value 2. For when the case when we are not able to connect, like for 3 and 1, we are taking the values horizontally, and here also we are taking the values horizontally. So we can actually take values in two ways horizontally. One is horizontally, the other one is vertically as well, because we are taking vertical values also, and between those two we are only taking the maximum value. Okay, because after at the end we want to return the maximum number of connections. Okay, so that is why we take the maximum value here, and then similarly we take the maximum value between these two, and for this one as well, since we are not able to connect 9 and 5, we take the maximum of these two. If we had a 5 here, then we would have been able to connect these two, right? And that in that case we would add 1 to this value 2. Okay, so basically this is a dynamic programming problem, and we are going to solve it using dynamic programming approach. So for that we are going to create a two-dimensional array with number of elements n plus 1 number of elements here, and also m plus 1 number of elements. Okay, so it will be y plus 1 because we are initially all the connections are equals to 0. Okay, and then when we create a new connection, we are taking the diagonal element and then adding a 1 to it. Okay, so we need a element, right? So there should be something to add on to, right? And something is the value 0, so that is why plus 1. Okay, and that is how we are going to perform our operation. So now let's try to code our solution. Okay, so for this what are we going to need? Let's see here. So we need a matrix of size n plus 1 and m plus 1. Okay, so let n1, I'm just going to represent n1 equals to nums 1 the length, and n2 equals to nums 2 that length. All right, now let us create our matrix, our dp matrix. Okay, dp matrix is equals to a new array of size n1, and then for let I equals to 0, I is less than it should be n1 plus 1 less than equals to n1 I plus plus, and there dp matrix we are going to create our sub array of length n2 plus 1. All right, now since we have our array, now what we do, we start from the first element. Okay, the first element, and then we compare, right? So we are comparing these values, and if these values are equal, then we create a new connection. Okay, and we are connecting at index I plus 1. All right, so let us start. So let I is equals to 0, I is less than all right, for loop, we need a for loop. So for let I is equals to 0, I is less than, and 1 plus 1 I plus plus, or we could just do less than equals to, and then for let j equals to 0, j is less than equals to n2 j plus plus. All right, now we are going to compare if nums 1 at index I is equals to nums 2 at index j. So if those two indices are equal, then we are going to add from our diagonal element, right? From the previous diagonal element. The previous diagonal element would be I minus 1 and j minus 1. Okay, so okay, we need a and that will be our current dp matrix value. So dp matrix I plus 1 j plus 1 will be equals to dp matrix I j plus 1. Alright, so now that we have it, else if the two numbers are not equal, then we are not able to connect, right? In that case, what are we going to do is the matrix value I plus 1 and j plus 1 will be equals to what do? We take either the previous row or the previous column. Okay, so that would be either this I minus 1 or j minus 1. So that would be I minus 1. We are doing I minus 1 here. All right, matrix. So matrix not matrix, math dot maximum value of dp matrix I j plus 1. So this would be the previous row or and between matrix I plus 1 j, that would represent the current row but current row but previous column. All right, so now that we have this, at the end we are going to return our answer will be stored in the last cell, that is at index I n1 plus 1 and j m1 n2 plus 1. Okay, so dp matrix n1 plus 1 n2 plus 1, that is where our answer will be stored. Now let's try to run our code and check. Oh, okay, so what went wrong? Cannot read properties of undefined. Oh, we are going to fill all of these with value 0. Okay, so we actually do not have, we only have n1 minus 1 elements, right, in nums1 and n2 minus 1 index, right, in nums2, and n1 minus 1 indices in nums1 as well, right? So that is what we are going to do, and similar will be the case for this one. So we are creating an array of length n1 plus 1 and n2 plus 1. Okay, so the last element would be n1 and n2. Awesome, now let's try to submit this. Great. So here let's talk about the space complexity and the time complexity. For the space complexity, since we are using a matrix of size n1 and n2, right, which depends on size of these two matrices, so that would be n times m time complexity. M, where n is the length of nums1, m is the length of nums2, and similar would be the space time complexity, because we are iterating over the length of both the arrays. Okay, so yeah, that is all about this problem solution. Let me know in the comments down below what do you think about my solution, and please don't forget to like my solution and subscribe to my channel for more LeetCode Daily Challenge solutions. Hope you'll have a great rest of your day. Thank you.